What if I told you there's a natural substance, something your own body already produces, that's being talked about as, well, maybe a foundational key to daily wellness,
Hmm.
like a shortcut to feeling better,
Wow.
potentially changing how we approach everything from, chronic pain and brain fog to even the really serious effects of conditions like Alzheimer's and Parkinson's?
It sounds almost too good to be true, doesn't it? But it's actually a remarkable reality.
It really is.
And the powerful molecule we're diving deep into today is called palmitoylethanolamide, or PEA for short.
Yeah.
Much easier to say.
PEA, right. And that's exactly our mission on this deep dive, to really unpack the huge amount of science behind PEA. We want to trace its really intriguing origins, look at the cutting-edge applications.
And understand how this body-owned compound works, right?
Yeah.
How it acts as this foundational regulator, not just for therapy, but for everyday well-being.
Exactly. We've sifted through a lot of research for you, stacks of papers, and we're going to pull out the most important nuggets of knowledge, those surprising insights, to give you a really comprehensive picture without, drowning you in data.
Sounds like a plan. Where should we start? The beginning.
Let's do it at the beginning. Where did this PEA story even start?
Well, it's actually surprisingly recent in the grand scheme of things, mid-20th century. It was first identified back in 1954.
Okay.
And not in some complex lab synthesis, but quite simply, in egg yolk.
Egg yolk. Seriously.
Think about that. A molecule that's now at the forefront of natural health research, first found in something as everyday as an egg. It kind of hints right away at its natural compatibility with us.
That's incredible. And I guess it didn't stop there.
No, not at all. The story expanded quickly. Just 3 years later, 1957, researchers found it wasn't just in eggs, but also in other really common food sources, things like soy lecithin, peanut flour.
Wow. Okay. So stuff we eat all the time.
Exactly. And that early identification in everyday foods immediately pointed towards its, well, exceptional safety profile, which is really critical when you're talking about compounds for health, right?
Absolutely. It suggests our bodies are already kind of familiar with it. It's not some foreign invader.
Precisely. It laid really important groundwork, because by 1965, the research had broadened out quite a bit, confirming PEA was, well, everywhere, ubiquitous across a whole range of mammalian tissues.
Like where specifically?
We're talking fundamental systems, the brain, the liver, muscle tissue. Its presence was widespread.
So that established it wasn't just some random finding.
Not at all. It established it as a highly conserved molecule, meaning biology keeps it around across species because it's vital. It's integral to basic mammalian biology. It's been playing this key regulatory role for, well, millions of years probably.
And the research didn't slow down after that, I take it.
Definitely not. It really gained momentum. Since those early days, we're not talking just a few studies. Over the following 50, 60 years, over 350 scientific papers have been published.
Wow.
Each one shedding more light on its diverse functions, its therapeutic effects. That really signals a robust scientific foundation. It underscores its relevance way beyond just being found in egg yolk. It sustained scientific interest and validation.
So, okay, it's natural, it's safe, it's well-researched, but what is it doing? How does it function in the body? I heard this term, oleamide.
Yes, oleamide. That's a fascinating classification. It stands for autocoid local injury antagonist amide.
Okay, that's a mouthful.
It is. But the term was actually coined by the team of Rita Levi-Montalcini.
The Nobel laureate.
The very one, which definitely adds some scientific weight, highlights its significance. These oleamides, they're naturally occurring fat-based molecules. They have inherent anti-inflammatory properties.
So they're part of the body's own response system.
Exactly. They're involved in the body's sophisticated self-response to inflammation, to injury, acting like intrinsic repair agents, like a natural internal first aid kit, if you will.
An internal first aid kit. I like that analogy. It makes sense. And you mentioned it's endogenous. Can you break that down a bit more? Why is that important?
Absolutely. Endogenous means it's made by the body. So when we call PEA an endogenous fatty acid amide, or a natural lipid mediator, the key phrase is that it's produced on demand.
On demand, so it's not just floating around all the time.
Right. It's not constantly circulating at high levels.
Yeah.
Instead, the body makes it precisely when and where it's needed to restore balance, that crucial internal stability, homeostasis.
When would the body demand it?
Particularly in response to stress, injury, or inflammation. You can think of it almost like an intelligent early stop signal for inflammation.
Ah, okay. Preventing things from spiraling out of control.
Precisely. It stops that cascade from causing more damage. It's really about the body's innate wisdom stepping in to regulate itself.
That distinction is huge. It's not just like putting a Band-Aid on symptoms. It's helping the body resolve the actual problem by activating its own healing.
Exactly. It's activating those internal mechanisms.
Which brings us back to that amazing safety profile you mentioned earlier.
Indeed. And this is one of the most critical aspects of PEA, something that genuinely sets it apart from many pharmaceutical options. It's safety.
Because it's natural.
Because it's natural, yes. Its presence throughout our body, brain, gut, everywhere, and being in common foods, that directly contributes to its high tolerability. We see this consistently across extensive animal studies, numerous human clinical trials.
It's reliable.
Very reliable in terms of safety. It makes it an incredibly attractive option for supplementation.
Yeah.
This natural compatibility means it works with our biology, right? It complements our systems rather than imposing some foreign mechanism. And that translates to a high level of comfort, adaptability for daily use.
That natural compatibility, working with our biology, that's a really profound advantage. So, okay, the next big question then is, if our body makes it, if it's in food, how does it actually work? What are the mechanisms, down at the cellular level that make it so powerful? Because people hear lipid mediator, and they often jump to the endocannabinoid system. But you said PEA is a bit different. It doesn't quite fit that classic cannabinoid mold.
That's a really perceptive point. While PEA is often described as an endocannabinoid-like lipid mediator, and it definitely shares similar metabolic processes with, say, anandamide.
Anandamide, the bliss molecule.
That's the one. But it's crucial to understand PEA doesn't directly bind to those classical cannabinoid receptors, CB1 and CB2, not in the same way THC or even CBD do.
Ah, okay. That's a common misunderstanding then.
It is, and understanding that distinction is really key to appreciating its unique mechanism.
So if it's not hitting CB1 and CB2 directly, where is the action happening? What's the primary way it exerts these profound effects?
The primary magic, as you put it, largely lies in its ability to activate a really crucial nuclear receptor called PPAR-alpha.
PPAR-alpha. Okay, what is that? Nuclear receptor sounds important.
It is. PPAR-alpha peroxisome proliferator activated receptor alpha. It isn't on the cell surface like CB1 or CB2. It's deep inside the cell, within the nucleus, the cell's control center.
Right, in the command center.
Exactly. And when PEA activates PPAR-alpha, it directly influences gene expression.
Gene expression. So it's actually changing how the cell operates.
At a fundamental level, yes.
Yep.
It's almost like rewriting a small part of the cell's operating manual. And this leads directly to its powerful anti-inflammatory and pain-relieving actions.
Wow. So it's not just flipping a switch on the surface, it's getting inside and changing the instructions. That's deep.
It is deep and far-reaching. It's influencing the cellular machinery to make more beneficial compounds, things that promote healing and balance, and fewer harmful ones that drive inflammation.
Makes sense.
But PEA's reach actually goes even further. It showcases this multi-target approach. It also interacts with other molecular targets, which broadens its therapeutic scope.
Like what else?
These include GPR55, which is sometimes called an orphan or unusual cannabinoid receptor. It has diverse roles all over the body. And also TRPV1 ion channels.
TRPV1, aren't those involved in pain? Like heat and pain sensation?
Exactly, those hot or pain receptors. PEA interacts with those too. So this multi-target engagement is really a hallmark of PEA's broad efficacy. It's why it can potentially help with so many different issues.
Okay, so genetic level via PPAR-alpha, other receptors like GPR55, even pain channels like TRPV1. But you mentioned something else earlier that sounded really critical, especially for inflammation and brain health, modulating glial cells and mast cells.
Ah, yes, the glial cells and mast cells. They are absolutely the, well, sometimes unsung heroes, sometimes the overzealous instigators of the nervous system's immune response.
Right.
And this is a truly key mechanism behind PEA's anti-inflammatory and neuroprotective effects. A huge part of its impact comes from its ability to control the overactivity of these non-neuronal cells.
Non-neuronal, so not the nerve cells themselves.
Right. Specifically mast cells and glial cells, which include microglia and astrocytes, both in the brain and out in the peripheral nervous system.
I usually think of neurons as the stars sending the signals, but these support cells sound like they do a lot of the heavy lifting, especially when inflammation flares up.
They absolutely do critical work. Mast cells, they're resident immune cells, often found strategically positioned near sensory nerves and blood vessels.
Okay.
When they get activated maybe by an injury, an allergen, they can rapidly release this whole cascade of inflammatory mediators. That contributes significantly to pain, swelling, local inflammation.
And the microglia and astrocytes, they're in the brain.
They are the brain and spinal cord's own dedicated immune and support cells. Now, when they become overactive due to stress, injury, disease, they start releasing powerful pro-inflammatory substances. Things like TNF-alpha, IL-1 beta, nitric oxide.
Those sound nasty.
They're essentially the body's alarm signals.
Mm-hmm.
But if they stay switched on too long, they amplify pain, damage neural tissue, and can even drive neurodegeneration.
So PEA is basically telling these sometimes overzealous immune cells to just calm down, settle down a bit.
That's a very good way to put it. PEA helps calm these cells. It prevents that excessive, prolonged release of harmful inflammatory chemicals. And crucially, it promotes the resolution of inflammation, not just suppression.
Resolution, not suppression. That sounds important.
It's a vital distinction. Truly resolving inflammation is key for long-term healing, restoring balance, preventing chronic issues from really taking hold.
Got it. And you mentioned PEA doesn't hit CB1 or CB2 directly, but it still influences the cannabinoid system through something called the Entourage Effect.
Ah, the Entourage Effect. Yes, I've definitely heard that term, especially with cannabis compounds. How does that work with PEA?
It works indirectly here. PEA can effectively boost the levels of other beneficial endogenous cannabinoids, like anandamide, that bliss molecule we mentioned.
That is, it boosts them by inhibiting the enzymes that normally break them down, specifically an enzyme called FAAH, fatty acetylamide hydrolase.
So it stops the cleanup crew, letting the good stuff hang around longer.
Exactly. By slowing down the breakdown of anandamide and potentially others, PEA helps them linger longer, have a greater effect. This creates a powerful synergy. It enhances the body's own natural pain-relieving and anti-inflammatory pathways.
That's incredibly clever. It's like a natural amplifier for your body's own defenses, making your internal systems work more efficiently.
Precisely. It's leveraging what's already there.
Okay, this all sounds incredibly promising. Powerful mechanisms, natural, safe. But I imagine getting a natural fat-based molecule like PEA into the body effectively might have been a challenge. Oral absorption can be tricky, right?
You're absolutely right to highlight that. Historically, that was a significant hurdle for PEA. Its absorption when taken orally was, well, notoriously poor.
So not much would get through.
Right, and that limited its therapeutic potential because not enough of the compound could reach the target tissues or cross the blood-brain barrier effectively to exert its full effects. It was a classic, great compound, poor delivery problem.
Okay, so how did they fix that? Because if it's so good, you want it to get where it needs to go.
This is where innovation in delivery systems became absolutely crucial. The development of advanced formulations, specifically micronized PEA, or MPEA, and especially ultramicronized PEA, PEA.
Micronized meaning smaller particles.
Exactly. Micronization reduces the particle size significantly. Ultramicronization goes even further. Most particles are typically below 6 microns, often above 0.5. This vastly increases the surface area for absorption in the gut.
Ah, like dissolving sand versus a rock in water.
That's a perfect analogy. The sand dissolves much faster, much more completely. These much smaller particles mean much better absorption.
So more gets into the bloodstream and can reach the tissues, including the brain.
Precisely. This improved absorption is absolutely crucial for its enhanced therapeutic effects in clinical applications. It makes it much easier, much more flexible to use as a daily supplement.
Any proof this works better?
Well, significantly, we've even seen regulatory recognition. For instance, the FDA approved the adjunct use of ultramicronized PEA for hospitalized COVID-19 patients.
Wow, really? For COVID?
Yes. That kind of regulatory nod for a naturally occurring compound, especially in a critical care setting like that, it speaks volumes about its safety and proven efficacy in the real world. It makes PEA a genuinely viable, practical option now for people seeking natural support.
That's a real game changer for actually using it effectively. Okay, so we've covered the science, how it works cellularly, calming those immune cells, influencing genes. Understanding the how really sets the stage for appreciating its diverse impact. Let's shift gears now from the micro mechanisms to the macro,
Sure.
whereas PEA making a real difference in clinical applications. Especially, let's start with pain. So many people struggle with that.
Pain management is definitely one of PEA's most extensively studied and, frankly, most promising clinical applications. And to really get how it works here, its multi-pronged approach, it helps to quickly understand the different types of pain.
Okay, lay it out for us. What are the main kinds?
Right. First, you have nociceptive pain. This is the pain from direct tissue injury or inflammation. Like a cut, a sprain, arthritis, a muscle strain, that kind of thing.
The straightforward, oh, that hurts kind of pain.
Pretty much. And PEA helps here by directly reducing that inflammation and stabilizing those mast cells we talked about, stops them from releasing all those pain-inducing chemicals that amplify the signal. It's addressing the body's immediate alarm.
Okay, makes sense for immediate injury. What about when the nerves themselves are the problem? That feels different.
That brings us to neuropathic pain. This is pain that arises from damage or disease affecting the nervous system itself, the nerves sending the signals.
Like what conditions?
Think diabetic neuropathy, sciatica, carpal tunnel syndrome, conditions where the nerves are directly damaged or compressed.
Okay.
Here, PEA's mechanisms are particularly beneficial. It calms those overactive immune cells in the nervous system, the microglia. It reduces the inflammatory chemicals that irritate nerves. It makes the nerve cells themselves less excitable, dialing down the pain signals.
Does it help protect the nerves too?
Yes, it even helps protect nerve fibers,
Yeah.
like the myelin sheath, the insulation around nerves that's often damaged in these conditions, so protecting it is crucial for function.
And then there's that third type, nociplastic pain. That sounds more mysterious. Like fibromyalgia.
It could be elusive, yeah. Nociplastic pain is characterized by widespread pain, but without clear evidence of tissue damage or nerve injury. Fibromyalgia is a classic example.
So where's the pain coming from?
It's thought to arise from changes in how the brain and spinal cord process pain signals. It's like the volume knob for pain is turned up too high centrally.
Ah, and PEA helps there how?
Well, PEA's ability to cross the blood-brain barrier and influence those brain immune cells, the glia, is thought to be particularly helpful here. It might help modulate this central processing of pain, kind of retune the brain's pain perception. That foundational regulation is why it's so promising for these complex conditions.
That covers a lot of pain territory. So what's the actual clinical evidence? Are there big studies showing it works for chronic pain?
There's increasingly strong evidence, yes. Multiple systematic reviews and meta-analyses. Those studies that combine data from many trials using strict guidelines, like PRISMA.
Right, the gold standard.
They consistently confirm PEA works. It reduces pain intensity across a wide range of chronic pain conditions. For instance, one meta-analysis looked at 8 studies covering both musculoskeletal and neuropathic pain, showed significant consistent pain reduction with PEA.
Can you give some specific examples? Where has it been particularly effective?
Sure. Take fibromyalgia. Notoriously difficult to treat, right? Often needs multiple approaches.
Definitely.
Well, an add-on therapy using PEA 600 milligrams twice daily combined with acetyl L-carnitine 500 milligrams twice daily for 12 weeks showed significant improvements, both in pain scores and overall disease severity scores.
And why is that so impactful for fibro sufferers?
Because unlike many standard treatments that just mask symptoms or involve heavy drugs, PEA seems to target that underlying neuroinflammatory issue. It offers a more foundational approach to managing this really complex and often debilitating condition. It offers real hope.
That is a big deal. What about more specific neuropathic pain, like from nerve damage, sciatica, diabetic pain?
The evidence there is also compelling. There was a major clinical trial, over 600 patients, 636 to be exact, with sciatic pain and lower back pain. PEA, at both 300 milligrams and 600 milligrams daily doses, was significantly effective compared to placebo in reducing pain.
Okay. And for diabetic neuropathy, that tingling and burning.
For diabetic peripheral neuropathy, DPN, studies show PEA helps reduce those painful symptoms, the electric shocks, the burning sensations. And it seems to improve nerve health, too, often used as an adjunct, alongside existing diabetic and pain meds. So it adds relief without messing with their current treatment.
What about carpal tunnel? Super common, affects sleep.
Yes. For carpal tunnel, ultramicronized PEA, again, 600 milligrams twice daily, significantly improved overall sleep quality. Patients reported longer, continuous sleep, less disturbance, and importantly, reduced pain both before and after surgery. That's crucial because pain totally disrupts sleep, creating that vicious cycle.
Absolutely. Any other nerve pain examples?
Well, there's chemotherapy-induced peripheral neuropathy, CIPN, a really severe side effect of cancer treatment. PEA has shown promise in restoring normal nerve fiber function there. Detailed clinical trial protocols are now outlining further investigation. It's a major area of unmet need for cancer survivors, so that's very hopeful.
Wow, that's quite a spectrum. Chronic widespread pain, specific nerve issues. Is it just for nerve pain or other types too, like facial pain or even headaches?
It's shown benefits beyond nerve pain, too, for various orofacial pain conditions, yes, including significant reduction in burning and intensity in burning mouth syndrome, which is often really tough to treat. and improved clinical markers in periodontal disease when added to standard treatment,
Mm-hmm.
and for headaches and migraines.
Yes.
A clinical study looked at a hydrodispersible PEA combined with melatonin called PEA. Used for episodic migraine, it showed significant reductions in migraine frequency, intensity, duration, and disability, plus improved quality of life with no reported side effects.
That sounds amazing for migraine sufferers.
It really does. And PEA also showed an excellent response in a specific case of something called nummular headache, supporting its role in modulating that trigeminal vascular system involved in many headaches.
So it seems incredibly versatile in the pain world. And what about using it as an add-on, complementing other treatments? That feels very practical.
That's a key aspect, absolutely. Its practical application. PEA is consistently highlighted as safe and remarkably well tolerated as an add-on therapy.
So you take it with your other meds.
Potentially, yes, under guidance, of course. It can enhance the effects of other pain relievers. This might even allow for lower doses of conventional drugs like NSAIDs.
Ibuprofen and Toroxin.
Right, which could reduce their potential side effects, especially with long-term use, which can be significant. It works synergistically, complementing the existing strategy. And crucially, it does this without causing the mind-altering effects you might get with some other cannabinoid-related compounds.
So enhancing, potentially making other treatments safer, not necessarily replacing them.
Got it. And just quickly, how do they even test pain in animals to figure this stuff out?
Well, they use standard tests, like the formalin test in rats, which measures persistent pain behaviors and inflammation. Studies using this showed PEA's dose-dependent pain reduction was remarkably comparable to drugs like morphine or agapentin.
Wow, comparable to morphine, without the side effects.
That's what the models suggest in terms of efficacy. And PEA also reduced thermal hypersensitivity, exaggerated pain from heat, and mechanical sensitivity in sciatic nerve injury models. These models really help confirm its robust pain-relieving properties and understand how it calms those pain signals.
That's a really thorough look at pain. Amazing. But PEA's impact goes way beyond just pain, doesn't it? I've seen so much about protecting the brain, cognitive health, even in conditions like Alzheimer's. How does it work there? Absolutely. This takes us into PEA's vital role in neuroprotection and cognitive health, particularly in neurodegenerative diseases, NDDs. These are conditions where nerve cells gradually die off, leading to a progressive loss of function, thinking, moving.
The really devastating ones. So what does it do for something huge like Alzheimer's?
Alzheimer's disease, AD, it's complex. You have the buildup of amyloid beta plaques, those neurofibrillary tangles from tau protein, and really crucially, significant brain inflammation, neuroinflammation.
Driven by those glial cells we talked about.
Largely, yes, that overactivation called reactive gliosis, where the support cells become destructive. PEA has shown remarkable effects in various AD mouse models. These are mice genetically engineered to mimic human AD.
What effects?
In these models, PEA improves cognitive deficits, reduced the toxicity from amyloid beta, significantly lowered brain inflammation and oxidative stress, and even helped restore altered molecular pathways seen in AD.
That sounds like it's hitting multiple key problems in Alzheimer's.
It is, which is exactly what you want. Specifically, ultramicronized PEA improved learning and memory problems in these models. It reduced high glutamate levels in the hippocampus.
The memory center.
Exactly. And it normalized inflammatory markers. This evidence strongly supports its potential for, well, rapid translation into clinical practice. Plus, studies show PEA reduced the activation of astrocytes, key support cells, caused specifically by amyloid beta. Again, highlighting its role in modulating these critical non-neuronal cells to fight neuroinflammation.
That's incredibly impressive. What about Parkinson's disease, another major neurodegenerative challenge?
Parkinson's, or PD, involves the loss of dopamine-producing neurons, crucial for movement. And, like Alzheimer's, brain inflammation plays a key role in driving the damage.
So can PEA help there too?
Research shows promise. Pre-treating aged mice with micronized PEA actually prevented the development of Parkinsonian symptoms. It improved behavior, protected dopamine markers, reduced brain inflammation, and even promoted neurogenesis, new brain cell growth in the hippocampus.
Wait, new brain cell growth? Not just slowing it down, but potentially repairing damage.
That's the incredible implication, yes.
Agree.
Promoting neurogenesis. The idea of encouraging the brain to repair itself is truly revolutionary. And in human studies, PEA, used as an adjuvant therapy in advanced PD patients, actually slowed disease progression and reduced disability. It suggests it can modulate brain activity and nerve signaling even in later stages, It offers real hope for improving quality of life.
So it's not just for the big two. What about other tough conditions like MS or ALS?
For multiple sclerosis, MS, which is autoimmune, inflammatory, and neurodegenerative ultramicronized PEA, as an add-on therapy for the relapsing remitting form, showed benefits. It improved pain, reduced injection site reactions often seen with standard drugs like interferon,
Right, those can be bothersome.
and enhanced overall quality of life, suggesting it can mitigate side effects of standard therapies. And for ALS, amyotrophic lateral sclerosis, that devastating motor neuron disease, PEA, often combined with luteolin, has shown improved clinical outcomes in case reports of sporadic ALS patients. It's preliminary, but promising.
It sounds like it could be really relevant for acute brain injuries too, like TDI or stroke, where inflammation runs rampant after the initial event and causes more damage.
Precisely. Secondary damage is a huge issue there. In traumatic brain injury, TBI, where that runaway inflammation happens after the impact, PEA helps maintain chemical balance, prevent further damage, reduce swelling, and overall brain injury. By protecting the neurovascular unit that critical guard the supply chain for the brain and reducing those inflammatory responses and harmful substances. Plus, studies suggest PEA improves memory and cognitive function when added to standard TBI treatment, vital for recovery.
And stroke, a leading cause of long-term disability, often with cognitive fallout.
Yes, acute ischemic stroke, AIS. Reduced blood supply followed by prolonged inflammation that worsens brain damage. Here, PEA, especially combined with luteolin as PLET.
The combination again.
Yes, that co-ultramicronized form. It showed significant brain protection in animal models. And crucially, in a study with 250 human stroke patients, PLET improved neurological status, reduced spasticity, boosted cognitive abilities, lessened pain, and increased independence in daily activities.
After how long?
After just 30 days of treatment.
Wow, that's fast and substantial, especially in that critical recovery window.
Exactly. And given that cognitive impairment hits over 40% of stroke survivors, PLET shows real promise in countering that worsening damage from post-stroke inflammation.
Okay, what about something more common, like brain fog? Something many people experience, maybe after COVID, or just general mild cognitive impairment. Very relatable.
Definitely. PEA's role in preventing brain inflammation and nerve cell damage in models of mild cognitive impairment, MCI, is being actively looked at as a preventative strategy. And for subjective cognitive impairment, what we often call brain fog, especially post-COVID,
Yes.
co-ultra-PLUT has shown both objective and subjective improvements. Better cognitive function, memory, general cognitive scores. This strongly supports the idea that modulating that brain inflammation, calming those glial cells, is key for resolving these persistent issues that affect daily clarity. It offers a path to regaining mental sharpness.
It's amazing how inflammation touches everything, injury, chronic disease, even just daily clarity. Can we learn more from animals that get similar issues naturally?
We absolutely can. Canine cognitive dysfunction syndrome, CCDS,
Yeah.
in older dogs and cats, it's an excellent natural model for human Alzheimer's.
Really? Dogs get dementia?
They do. Similar cognitive decline, confusion, behavioral changes. And in these pets, PEA has shown potential to rebalance inflammation, protect brain cells, leading to measurable improvements in their age-related cognitive problems. It provides a compelling parallel, validating PEA's broad neuroprotective properties across species.
Okay, so pain, brain protection. What about mental health, mood? Is PEA showing up there too, given its influence on brain chemistry and inflammation?
Yes, this is a rapidly emerging and really exciting frontier for PEA. Highlights its broad impact on overall well-being.
How so?
In mouse models, PEA showed significant antidepressant effects, comparable to common antidepressants like fluoxetine, but importantly, without affecting general activity levels.
So not sedating, just targeting mood.
Exactly. Suggests a specific impact on mood regulation. And it's not just PEA alone here either, right? Combinations again.
Yes, indeed. That combination of PEA and luteolin again demonstrated significant antidepressant effects in animal models, promoting neurogenesis, new brain cell growth, and neuroplasticity, the brain's ability to adapt and form new connections. So helping the brain heal and adapt, which is crucial for mood resilience.
Oh, precisely. And in obesity-induced anxiety, PEA improved anxiety behaviors, reduced systemic inflammation, increased beneficial neurotransmitters like dopamine and GABA in the amygdala.
The emotion center.
Right? And even helped repair the blood-brain barrier, which can be leaky under stress. Interestingly, studies found PEA levels seem to correlate with resilience. Higher PEA in more resilient individuals, lower PEA in those with higher anxiety. Suggests it could be a marker for stress coping.
That's a profound connection. PEA levels and stress resilience. What about more severe conditions like psychosis, schizophrenia, bipolar?
Its effects on brain inflammation and glutamate signaling, that excitatory neurotransmitter that can be off-kilter, are being explored for potential use in psychosis. Studies have noted lower PEA levels in brain tissue of schizophrenia patients compared to controls.
Suggesting a possible role in the pathology.
Possibly. And as an add-on treatment in bipolar disorder, PEA, along with other compounds, showed statistically significant reductions in manic symptoms, highlighting potential as a supportive therapy.
And autism spectrum disorder, ASD, any connection there?
It's being researched for ASD, too. Given the known issues with inflammation and glutamate signaling in autism, pathways PEA modulates. Studies are exploring effects on neuronal damage, its anticonvulsant properties, since seizures can be common in ASD. The idea is to see if calming these underlying issues can help symptoms.
It feels like PEA is involved everywhere, from physical pain to brain function, mood. Could there be an even broader link, like the gut? The gut-brain axis is huge now.
Absolutely. The gut-brain axis is critical, and bioactive lipids, including PEA, are crucial for gut health and its complex interaction with the brain.
How does PEA help the gut?
It has significant anti-inflammatory effects directly on gut tissue, like in IBD models. It can counteract protein buildup in the gut linked to neurodegenerative disorders, suggesting brain benefits via the gut. And it reduces intestinal permeability, leaky gut, helps strengthen that barrier.
So keeping the gut barrier strong helps overall health.
Critically important for systemic health. And speaking of systemic, any other promising areas?
Several other interesting ones are emerging. Ophthalmic diseases, eye health. PEA showed ocular hypertensive effects, lowering eye pressure, like for glaucoma.
Exactly. In clinical trials for glaucoma, its combination with lycopene is even patented for inflammatory eye diseases. And PEA and other endocannabinoids are naturally found in human eye tissues, suggesting an innate role.
What else? Skin, liver.
Skin health, yes. Investigated for inflammatory skin diseases, shown benefits for dry, itchy skin, ascitotic eczema. Studies on its effects on UV-damaged skin cells, too. And liver health. It's relevant in understanding metabolic dysfunction-associated steatotic liver disease, MASLD, or fatty liver disease. And even the neuromuscular junction, where nerves meet muscles. PEA can modulate its function by binding to acetylcholine receptors, potential for neuromuscular conditions. It's truly a multi-system foundational molecule.
It really is staggering how many different systems, different conditions PEA touches, from the cellular level right up to broad health. And what seems even more powerful, based on the sources, is when PEA teams up with other compounds, like a natural superhero team. Let's dive into those combinations, starting with one you've mentioned a few times, PEA and luteolin.
Ah, yes, PEA and luteolin, often PEALET or co-ultrapilate. This combination is a frequent star in the research. It consistently shows enhanced brain protective, anti-inflammatory, and antioxidant effects, often significantly more effective than PEA alone, even when PEA itself is already doing good work. True synergy.
Where have we seen this synergy really shine? Give us some examples.
Okay, animal models of anxiety depression. This combo showed significant antidepressant effects, promoted neurogenesis, neuroplasticity, things PEA alone didn't fully achieve. Lab models of Alzheimer's. PEALUT, normalized inflammatory markers, prevented nerve cell death in ways neither compound could do alone. Real combined power.
A definite step up. And in humans, what benefits are seen?
Human studies on frontotemporal dementia, a tough neurodegenerative condition. Patients saw improved cognitive scores, better daily activities, even restored brain activity patterns after just 4 weeks of PEALUT, 700 milligrams twice daily. Stroke patients, profound improvements. Neurological status, spasticity, cognition, pain, independence, and daily activities, again, after only 30 days. Rapid, comprehensive impact.
And for that frustrating post-COVID brain fog.
Yeah. For subjective cognitive impairment, brain fog, particularly post-COVID. Co-ultrapilate showed both objective and subjective improvements. Cognition, memory, general assessments. It also significantly helped with smell recovery, olfactory dysfunction, by promoting regeneration and reducing neuroinflammation in the nasal passages and olfactory bulb. It really tackles multiple angles of these neurological issues.
What about PEA with acetyl L-carnitine? You mentioned it for fibromyalgia. Is there more to that team up?
Yes, that PEA plus ALC combo, great for fibromyalgia pain and severity. But the synergy seems broader. It's also proven effective for neuropathies linked to rheumatic diseases. Suggests a powerful synergistic anti-inflammatory effect, where ALC supports nerve health and energy, while PEA calms the inflammation.
It is compelling and practically significant. When low doses of hemp oil extract, HOE, and PEA were combined in mouse models, the pain reduction was significantly greater than additive.
Meaning 1 plus 1 equals more than 2. Exactly. The effect was amplified. Research suggests the HOE actually seems to improve PEA's absorption and prolong its effects in the body, which explains the potent synergy and suggests a highly efficient delivery method.
Improving delivery again. Key factor. And you mentioned PEA. What's special there?
PEA is a novel combo, PEA plus Equisetum arvens L, or horsetail extract. It was specifically designed to tackle PEA's old absorption problem, like micronization did.
How does it perform?
It's shown synergistic benefits for nerve recovery, reduces inflammation, oxidative stress, boosts CB1, CB2, and GABA systems crucial for pain regulation and calming nerves, and protects the myelin sheath in neuropathic pain models. It aims for better absorption and multifaceted nerve support.
Any other standout combinations we should be aware of?
Definitely. PEA plus melatonin as P90. Yeah. Very effective for migraine management, reducing frequency, intensity, duration, disability, significant relief. PEA plus rutin, a flavonoid, reduced vascular injury, inflammation, oxidative stress. PEA plus quercetin plus curcuminoids, powerful anti-inflammatories together synergistically reduced pro-inflammatory markers, reactive oxygen species, nitric oxide, and PEA plus lipoic acid plus vitamin D3 showed improved absorption, reduced harmful reactive oxygen species and nitric oxide, and interacted with cannabinoid and estrogen receptors to cut inflammation. The power in these combinations is truly striking, leveraging PEA's unique properties in multiple ways.
This has been an incredibly comprehensive deep dive into palmitoylethanolamide, PEA. It's crystal clear this isn't just, another supplement. It's a naturally occurring body-owned lipid mediator, remarkable safety, incredible ability to influence our physiology. So as we wrap up, what's the bottom line? What does this all mean for us, the listeners, in our daily lives? What's PEA's unique value?
I think its unique value really lies in its fundamental intelligent approach. It's not just an external substance. It's something your own body makes, designed to restore balance at a really deep cellular level. Its ability to hit multiple targets, nuclear receptors, changing gene expression, calming those crucial immune cells makes it incredibly versatile. It truly works with your body's own wisdom, a partner in health.
So it's much more than just masking symptoms, right? It's getting at the root causes.
Precisely. PEA moves beyond symptom masking. It actively addresses the underlying mechanisms, the inflammation, the cellular imbalance that contribute to so many chronic conditions. It's not just suppressing the fire, it's helping the body resolve it, put it out, repair the damage. That makes it a very promising foundational tool for long-term well-being.
And its role as an add-on therapy. You mentioned combinations enhancing effects.
Its potential as a valuable adjunct therapy is immense. It can be safely used alongside conventional treatments, offering enhanced benefits, potentially allowing for lower doses of other meds, which can mean fewer side effects. And crucially, it does all this without the mind-altering effects some other cannabinoids might have. That makes it highly desirable for daily use, supporting health without cognitive compromise.
It really feels like this empowers your own wellness journey. Knowing about something like PEA gives you a different perspective, doesn't it, on how to approach health, not just when things go wrong, but proactively, daily.
Indeed. Understanding PEA offers you, the listener, a powerful tool. Whether you're dealing with chronic pain, looking to support cognitive function, seeking clarity, or trying to modulate that systemic inflammation underlying so many modern issues, PEA represents a natural, well-researched way to support your body's innate ability to heal and find balance. It's truly about proactive self-care.
It really makes you think, doesn't it? Considering PEA's incredible ability to help the body restore its own balance from the brain down to the gut, it raises a big question for all of us. What other body-owned molecules might we unlock in the future? How could that revolutionize our approach to daily wellness and chronic disease?
It really points towards a potential paradigm shift, doesn't it? We're moving from just broad interventions to precision support that works with our natural biology, leveraging the wisdom already within us.
Exactly, tapping into that innate wisdom our bodies possess, rather than always just adding external things. So a final thought for everyone listening. Where do you think PEA might fit into your own understanding of holistic health after hearing all this? It's a powerful idea to sit with how we can best support our body's own incredible capacity for balance and healing.